Bayes' theorem. Bayes' theorem is a powerful tool for reversing conditional probabilities. Often we know information like the probability of B given A, but what we want is the probability of A given B. This has a lot of use out there in the real world. I know it's used a lot in medical research, but I've even seen it used to look at historical claims. Bayes' theorem provides the link. We have seen and used the formula, the probability of A given B is equal to the probability of A and B over the probability of B. And it follows that the probability of B given A is the probability of A and B. Remember, A and B and A is the same thing, divided by the probability of A. So, the probability of A and B is the probability of A given B times the probability of B. And the probability of A and B is also equal to the probability of B given A times the probability of A. Since both of those are equal to the probability of A and B, it follows that they're equal to each other. The probability of A given B times the probability of B is equal to the probability of B given A times the probability of A, which may be written as the probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B. This last equation is Bayes' theorem. Further, the probability of B is the probability of B and A times the probability of B and not A. We've seen this in examples on tree diagrams where we have a sort of A and not A situation, B, not B, B, not B. And if we want the B's, we've got A and B, and we've got not A and B. And we would add those together to find the probability of B. So from there, we get the probability of B given A times the probability of A, plus the probability of B given not A times the probability of A, as illustrated on this diagram. So this one here being B given not A, and this one here being B given A. So the equation above may be written, probability of A given B is the probability of B given A times the probability of A, and then the probability of B is the probability of B given A times the probability of A, plus the probability of B given not A times the probability of not A. And we used this in one of our earlier examples.